So when talking about rates of reaction, which is more important and which one's going on? Is it actually just increasing the collision rate? And when we say increasing the collision rate, we are, lost my pen, there it is. We are talking about increasing the chances that particular collision will have enough energy and that the collision will also be in the correct 3D orientation. Or something that is slightly new is the temperature and the catalyst. Now, surface area, concentration, pressure, and temperature are actually all working together to increase the rate of collisions, which is the collision theory, and therefore increasing the chance that it'll have enough energy and in the right place. But temperature and catalyst are also having an effect on the activation energy. Now, of course, the catalyst is decreasing the activation energy and therefore making it much easier for a higher proportion of molecules to be able to get over that, have enough energy to reach that activation energy. Temperature is acting slightly differently, and it's doing the same thing. It's raising the potential energy of everything. And so if you raise these reactants to a new higher level, and also raise the products to a new higher level, you'll see that also decreases the activation energy of both sides. And so both temperature and catalyst are acting to decrease the size of the activation energy. One's reducing it from this direction, and temperature is reducing it by raising the bar, or raising the average of all the molecules up, so they innately have more energy to overcome the activation energy, whereas catalysts are decreasing the amount of activation energy needed and not increasing the innate average kinetic energy or temperature, average kinetic energy temperature of the products and reactants, whether it's going in an endothermic direction or exothermic direction. Okay, so that's just a quick explanation of rates of reaction, whether you need to talk about collision theory, or whether you need to talk about activation energy, or whether you need to talk about both in your experiments, which is the next topic.